After doing the Clemenson's reduction and Wolff-Kirschner's reduction, we'll see other reactions of carboxylic acids. So some 7 reactions we have to do today. Out of that, the first reaction is reaction with PCl3, phosphorus trichloride. Acetic acid reacts with phosphorus trichloride and forms acetyl chloride. That is CH3CO and Cl, acetyl chloride. So OH is replaced by Cl here. The OH group is replaced by Cl and we have formation of H3PO3. This reaction is utilizing 3 molecules of acetic acid. Next is reaction with PCl5, phosphorus pentachloride. Acetic acid reacts with phosphorus pentachloride. Temperature is required here. Again, there is formation of acetyl chloride where OH group is getting replaced by Cl. And along with that, there is phosphorus oxychloride formed, POCl3 and HCl. Now, if you compare the two reactions, it must be noted that when we use PCl5, we are using only one molecule of acetic acid here. But when we are using PCl3, there are 3 molecules of acetic acid used because the byproduct formed is only H3PO3. Here 2 byproducts are formed, POCl3 and HCl. Next is reaction with thionyl chloride or sulfonyl chloride. So acetic acid reacts with SOCl2. Temperature is required here. It forms again acetyl chloride, CH3COCl. OH gets replaced again by Cl. Along with that, there is formation of SO2. From OH, oxygen combines with SO to form SO2 and HCl. The remaining Cl combines with H and forms HCl. The important part about the reaction is the byproducts SO2 and HCl which are formed here, both are gaseous in nature. So both of them escape during the reaction. Next reaction is with ammonia. Acetic acid reacts with ammonia, which is a reversible reaction, to form ammonium acetate. That is, ammonium salt of carboxylic acid is formed. Whatever acid we are using here, the ammonium salt is formed. That is, H combines with NH3 and NH4. So the earlier group remains as it is, CH3COO, but along with that, NH4 is formed, ammonium group comes here. So ammonium acetate is formed. If you change the acid, the name will change here, but ammonium word will remain common. So ammonium acetate, when heated now, loses water molecule. There is loss of water molecule. 2 from NH4, 2H from NH4 and 1 from oxygen go out. H2O goes out during the reaction and there is formation of CH3CO and NH2, which is called acetamide. Acetamide is formed. So ammonium salt has got converted to acetamide. Next is reaction with P2O5. Reaction with P2O5. P2O5 is a dehydrating agent. It removes the water molecule from the substrate. So we require 2 molecules of acetic acid. When 2 molecules of acetic acid are heated in presence of P2O5 and concentrated H2SO4, which are very strong dehydrating agents, that is, they are removing the water molecule, there is formation of acetic anhydride. What is seen in the reaction? Now these are 2 molecules of acetic acid. Out of 2 molecules, OH and H, this is lost, and this oxygen atom acts as a bridge between the 2 CH3CO groups and there is formation of acetic anhydride. H2O is lost during the reaction. If it is needed to increase the yield of acetic anhydride, Then sodium acetate, that is sodium salt of acetic acid, is treated with acetyl chloride. So sodium acetate treated with acetyl chloride, CH3COCl, acetyl chloride. We have done this in 11th also. When they are heated together, there is CH3COO from sodium acetate and CH3CO from acetyl chloride, combining and forming acetic anhydride. This is acetic anhydride here. Remaining NaCl is formed as a byproduct. Next reaction is decarboxylation of carboxylic acid. Decarboxylation is removal of CO2 from the substrate molecule, is called as decarboxylation. So from carboxylic acid, but in the book heading is given decarboxylation of carboxylic acid, but the reaction is shown of sodium salt of carboxylic acid. From sodium salt of carboxylic acid, decarboxylation, that is CO2 group will be removed, will be lost by treating that sodium salt of acid with soda lime. What is soda lime? It is mixture of NaOH and CaO. So let's see an example. Sodium acetate. This is sodium salt of acetic acid. Sodium acetate is treated with soda lime, NaOH and CaO. This mixture is heated. There is loss of CO2. This CO2 is going out. Na also moves out and H is introduced with CH3 group and forms methane. The remaining form Na2 and CO3. Na2CO3. Sodium carbonate is the byproduct. So in the reaction there is formation of hydrocarbon. Alkane is formed here in the reaction when we are doing decarboxylation of carboxylic acid. The speciality of the reaction is when we started with the substrate, that is sodium salt of carboxylic acid, we had 2 carbon atoms in the compound, in the substrate molecule. But the product that is formed has 1 carbon less than the substrate, that is than the reactant. Because CO2 group is going out, so 1 carbon is becoming less. In the product you will find 1 carbon atom less than the reactant. So in the reactant, as 2 carbons are there, in the product you find only 1 carbon atom present. And the last reaction is reduction of carboxylic acid. Reducing agents, we have studied many reducing agents. One of them is LiAlH4, lithium aluminium hydride. This is one of the reducing agents. They are very strong. This is a very strong reducing agent. Acetic acid, when treated with lithium aluminium hydride in presence of dry ether, forms ethanol. What is seen in the reaction? The C double bond O, that is carbonyl group from the acid, is converted to CH2 group. Oxygen is going out and 2 hydrogen atoms are introduced with carbon, and there is formation of a primary alcohol, ethanol. So we can change the acids, we can use different acid. Book is giving only general reaction, but we can try different R groups and see that you are getting formation of a primary alcohol. So this completes the reactions of carboxylic acids.